Hello everybody, today we will be going over a normal distribution problem at the IB Masteries level. So we have the lifetime L of light bulbs made by a company, which follows a normal distribution. We have that L is measured in hours, as we can see over here in the bottom, that the normal distribution of the curve L is shown below. And so for part A, we need to write down the mean lifetime of the light bulbs. Now in any normal distribution, the mean is always going to be the number that is straight down the middle. Okay, so easy peasy, we can literally just write down 5,800 hours and we're good to go. The deeper explanation of this is that every single normal distribution is going to look like this. It is going to have some sort of bell form. We will have the the mean right down the middle. And periodically to the left and right, we're going to have the mean minus the standard deviation. And on the right side, the mean plus the standard deviation. Now, why does this make sense? This makes sense because, first things first, the mean intuitively is like the average, your average values in your data set, while your standard deviation is kind of like the dispersion from the mean, okay? From your normal values that show up. And so it makes sense that we have the mean minus the standard deviation, and this area here would cover the majority of the curve. In fact, if you look at actual numbers, this is usually like 34% plus 34% or something like that. Okay? And so one standard deviation over is the majority of the curve. If we're talking about two standard deviations over, like the one over here, then the dispersion is much bigger. Okay? But that is the general intuition of standard deviation. Now, why do I say this? Because we're going to need to know the mean and the standard deviation for all of these problems to be able to plug and chug into the calculator. And so a lot of people approach this problem and they go, hey, it was taught to me, which is correct. It was taught to me that normal distributions look like this. Okay? And so they go here and say, hey, this line here of 5,200 is going to be my mean minus standard deviation. Okay? And then they go ahead and say 5,800 minus 5,200 is going to give me my standard deviation, which is 600. Okay, and this seems incredibly logical, but some problems give you the standard deviation, and they tell us that the standard deviation here is 850. Okay, and so that is a way in which they try to trick you into writing down the wrong standard deviation. Okay, so just keep it in mind. If they don't give you this, in a world where they don't give you this, most of the time, it is safe to assume to do this process here. It is safe to do that, unless if they give you the standard deviation, okay? So just keep that in mind as a general rule. Anyway, moving on, we have part B. We can find the probability that a light bulb of minimum 5,000 hours of lifetime and maximum 6,000 hours of lifetime is randomly chosen, and what is the probability that we choose one of those? Okay, in other words, what the question is asking us is if we have the area of 5,000 here and the area of 6,000 here, sorry, those two like lines, what is the area that encompasses in between it? And given that area, what is the probability, right? And so, what useful information do we have up until now? We have the mean, right? 5,800, and we have the standard deviation, 850. Now this right here is literally half of what you need already. We haven't even begun to think how to solve the problem, and we already have half the information that we need. And so the information that we need is knowing which function to use. And so if you go to the calculator, we are working with distributions. And so you can go to tap second and click vars, so that effectively we hit the blue word here, which says distribution. And here we have a bunch of functions, okay? The ones that you're going to be using the most is, at least in my experience, normalCDF and inverse normal. In this scenario, we're going to use normalCDF. What you're doing in normalCDF is giving it a lower value and an upper value, giving it the mean and the standard deviation, and it's going to spit out an area. It's going to spit out a probability, and it's going to spit out what we need over here. Okay? And so our lower, very intuitively, is 5,000, and our upper is 6,000. Something that helps a lot in these problems is being very, very visual about it. The 5,000 and the L being greater than 5,000 and less than 6,000 is drawn here. Okay, and so once you draw it onto your graph, it is much easier to understand your lower and upper values and what you have to plug in. So I strongly suggest that you do that. And so I'm going to plug in for lower 5,000, for upper 6,000. For the weird symbol here, we know that it's the mean, 5,800, and the standard deviation, 850. Trust the process always. Bada bim, bada boom, click paste. Press enter again, and it spits out 0.4197. Okay, 0.4197. And so here, it is telling us that it is around 41.97%. Okay, the probability to pick a light bulb with at least 5,000 hours of lifetime and a maximum of 6,000 is 41.97%. Then they tell us, that is for part B, okay? For part C, they tell us that the company states that 90% of the light bulbs have a lifetime of at least K hours, and to find the value of K, and to give our answer correct to the nearest 100. So let's not forget that detail here. Effectively, here we need to use a different function, but we also already have all the information that we need. Again, we're going to be using mean and standard deviation, so it's very important that you try to catch on to that immediately when working with normal distributions. And the also important information is the 90%, okay? The formula, the function that we have to use now is inverse normal, is the third one over here. What inverse normal does is that you give it an area and it's going to spit out an amount, okay? Notice that in the other one, in normal CDF, we gave it its, oops, I don't know what happened there. In normal CDF, we gave it its parameters, its lower and upper, and it spit out an area. And here in inventory normal, it's the other way around. We're going to give it an area, it's going to spit out a number, okay? And so the way it works is that it reads it left to right. If I have my normal distribution here, and I give it, let's say, 40% of the function, what if I give it an area of 0.4 in the function here, what I mean is literally putting 0.4 over here, it's going to spit out the amount of light bulbs over here. Now, why does it work like that? Because it is inverse normal, okay? I know it's not too intuitive, but one part that helps us is that it's inverse, okay? If they tell us that 90% of the light bulbs have a lifetime of at least K hours, effectively, we need to find in our bell here the upper 90%, right? And so a very common mistake is that people here plug in 90%, but plugging in 90% here would actually be asking it for this black area here, right? It would assume that, hey, all of this is 90%, and it's going to spit out this 10% here. And so what we have to do, actually, is plug in 0.1 for our area, which is this here, and it's going to spit out the upper 90%. And that it also makes sense because it is asking for at least K hours. And so if we go ahead and plug in 0.1 here, plug in our area, our mean, which is 5,800, and our standard deviation, which is H50, plug and chug, We end up with 4,710, and we give our answer correct to the nearest 100. We end up that for part C is 4,700 light bulbs. Okay, so that is for part C. Now, I know that a lot of this might seem confusing, but the biggest part, for me at least, is having clear what is your mean, what is your standard deviation, don't fall into those classic traps, and then just getting familiar with which function to use when and why it makes sense. Okay? If you want to memorize it and be like, okay, this one spits out an area, a probability, and this one spits out a number, you know, you can remember it like that. Okay? But I think it's also very important to understand visually what is going on. And that is how you integrate it into your knowledge on a deeper level more than just memorizing. So I strongly suggest that you think about it in a visual manner, and all of this will make so much more sense. So, that being said, that is how you solve this problem, and I hope it helped. Peace.